All right, this is Algebra 2. We are in lesson 5.2. Picking up, this is part 2. We are factoring trinomials that have a value other than 1 for a. So ax squared plus bx plus c. So right here, we're factoring 2x squared plus 13x plus 6. This 2 right here adds a whole new level of difficulty to this problem. Just the fact that there's a 2 there. Um, you want 2x squared plus 3x plus 6 to equal, now right here it says kx plus m times lx plus n, where k and l are factors of 2. So we're going to do the same thing. You're going to factor out a's value. There's only 2 and 1. That's all you can use. And m and n are positive factors of 6. So right here you see how it's positive, the m and the n. So the numbers that we're going to multiply by have to be positive factors of 6. So we could check these factors by multiplying. So what we're going to do, instead of setting up a set of two sets of parentheses where we just put x and x like we've been doing when the value is 1, now we're going to put 2, and we'll just put 1 right here where we can look at it for right now. So 2x times 1x, because that's the way we're going to get to 2x squared. So from there, we still want to factor out our c value 6. So 6, we still only have 1 and 6 and 2 and 3. Those are the only two pairs of factors we can use. So now we have 2 and 1. If we use the numbers 2 or 1 and 6, let's just go through them. And this is what I mean by it taking a little bit longer. 2 and 6 and 1 and 2, or 1 and 6 and 2 and 1. If we FOIL this, remember what FOIL means, F-O-I-L. F means you're going to multiply 2x times x, or 1x, and get 2x squared. So mentally, you're going to have to do some FOILing where you don't take a whole lot of space. 2x squared. The O in FOIL means to multiply the outside ones, 2x times 6. Again, we don't have positives and negatives up here yet. So 2 times 6 is going to be 12x. The I in FOIL stands for the inner two terms, 1 times 1x, so 1x. And then L stands for the last two terms, 1 and 6, gives us 6. So right here we have 2x squared and we have 6. So that's what you want to check, to make sure you have 2x squared and 6, which we do. And then when you put your like terms together, again, we don't have a positive or negative value yet. But when you put 1x and 2 and 12x together, you're either going to get 11x or you're going to get 13x based on a sign, just like a little while ago. 13x is the one we want. So these are the factors we're actually going to use. We're going to use 6 and 1 as opposed to using 2 and 3. Now on this paper, it tells you to do all of them. Now all of them really is just positives and negatives of the numbers 1 and 6 and 2 and 3 if you look at it. And right here, all this is foiling all 4 of these back out, which is what I showed just a second ago. Just foil them all back out. Okay. But the one that comes back to the quadratic or the trinomial that we have, the only one that comes back to it is this one here, 1 and 6, when it's combined with 2 and 1, because 2x times 1x. So again, the same thing. The sign right here tells you they're the same sign. They're both either positive or negative, and the sign right here tells you they're both positive. So 2x squared plus 13x plus 6. Therefore, the correct factorization is 2x plus 1 times x plus 6. When we do more of these, it makes a little bit more sense as you do them and as you practice them. It is just a little bit more tedious than having 1 as your a value. So again, in the blank space on the side, everybody, let's factor out this one. 4y squared minus 4y, those are y's, doesn't matter y's or v's or whatever, 4y minus 3. Take about a minute on that one. Let's take a look at it. There isn't, unlike the example where it had to be 2 and 1, because if you looked at A's value, it was 2. So it had to be 2 and 1. Our A value of this problem is 4. So it could actually be 4 and 1, or it could be 2 and 2. So there's two different options. There's two different pairs of factors. What you want to do from there before you start doing all kind of tedious work is you want to look at your C value. Your C value is 3. There's only one pair of numbers that gets you to 3. So if one of them has 2, check and see if the other one has 1. So we have to use the number 1 and 3. So right here, we could plug in the numbers 1 and 3 and 1 and 3, just as we're looking at them both ways. Now, we may have to use 3 and 1 instead, since we have 4y and 1y. So it's not going to matter order-wise for these two because both of them are 2. So that it's not going to make a difference. So for this one over here, let's add one more. 4y and 1y. And instead of having it say 1 and 3, let's have it say 3 and 1. Now this is going to make up all of our possible outcomes right here. All these 3 pairs right here. Okay. Remember, this sign right here, the same thing like earlier, this one tells you they're either the same or they're different. It's negative, so they're going to be different signs. Since they're different, this one tells you the bigger one is negative. So if that holds true, -3, +1, -3, +1, -3, +1. Which one of these pairs gets you back to your original trinomial 4y squared minus 4y minus 3? That's what we're going to determine now. So if we FOIL 4y times 1y for that one, you're going to get 4y squared. Outer terms, 4y times -3 is -12y. Inner terms, 1y times y is plus 1y. So right here, let's look before we do any more. If we put those two together, how many y's are we going to get? We're going to get -11y, more specifically here, which is not 4y. So this pair of factors that one does not work. Let's do the same with the one right below it, just to show why it works or it doesn't. 4y squared plus 4y minus 3y. Again, let's evaluate it at that point. 4y minus 3y is how many y's? 1y. This one doesn't work either. Let's do the other one. 2y times 2y, 4y squared. 2y times -3y, -6y. 1 times 2y is plus 2y. Let's stop there again. What do we get when we put these two together? And it's -6 and +2, so it'll more specifically be -4y. So we have 4y squared minus 4y. That's what we were trying to get. And then your last two terms, 1 times -3 is -3. So that is the same trinomial as what we started with. Therefore, this is the answer to factoring it out. 2y plus 1 times 2y minus 3. This is what I meant that by it not being really more difficult, it's just more work. So it feels like it's more difficult. Now, when you get to special patterns, it's a whole lot easier. These are much, much easier than factoring with a as 1 or even a as something different besides 1. When you're talking about the difference of two perfect squares, or just a lot of times I'll say perfect squares. Right here it just says the difference of two squares. It's just going to be a plus b times a minus b. So right here, x squared is a perfect square. You can multiply x times x to get that. You could take the square root of that. It's just x. And 9, you could take the square root of that. It's just 3. Remember, your perfect squares, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5, 6 times 6, 7 times 7. Those numbers are your perfect squares. If you're talking about the difference of one of those numbers, it's just a plus b times a minus b. So x squared minus 9 is x plus 3 times x minus 6. That's the difference of two squares. When you're talking about a perfect square trinomial, such as x squared plus 12x plus 36, the only thing you have to check to see if it's a perfect trinomial is check a's value. Is a perfect square? You can multiply x times x, so yes. And is c's value a perfect square? You can multiply 6 times 6 and get that. So you put x and you put 6. This sign right here in front of b is the sign that goes in between them. So x plus 6 squared. So when you're looking at something a squared plus 2ab plus b squared, it's simply a, and the plus comes in again because this one's plus. That's why it's plus b squared. When we look at completing squares in a couple of lessons, that this one will make a little bit better sense. This one right here, notice it says minus here. That's why it's minus there. So again, this one's a perfect square, x. This one's a perfect square, 4. This is the sign right here before b, negative. Therefore, negative goes between them, or minus goes between them. X minus 4 squared. So these are your three special factor patterns when you're talking about the difference of perfect squares, or when you're talking about perfect square trinomials with a negative or positive in front of b. Again, this is new stuff, everybody, so don't lose heart if it looks tough. Example number 3 says factoring the quadratic expression 9x squared minus 16. This is the difference of two perfect squares. 9 is a perfect square. 3 times 3 gives you 9. X squared is a perfect square, so together they're still a perfect square. 3x squared. Remember, difference means minus. It says minus in between them. And 16 is a perfect square, 4. So 3x squared minus 4 squared is the difference of those two. 3x plus 4, 3x minus 4. You can factor it out the same way we've been factoring it out, but you're going to wind up foiling it back to plus and minus. So it saves you a whole lot of work to simply write it as a plus b times a minus b. In this case, 3x plus 4 times 3x minus 4. Here's the other one, perfect square trinomial. 16 is a perfect square, 4. Y squared is a perfect square, y. 25 is a perfect square, 5. So 4y plus 5, notice all of this part is eliminated. 4y, all you get from that right there is the plus. Plus 5 squared. And again, as we do more examples, this will start to make more sense. And then this one is with minus in between. 64 is a perfect square. What is the square root of 64? 8. X squared is a perfect square. What's the square root of x squared? X. So it's 8x squared. 4 is a perfect square, 2. This is the sign that goes in between them, the one in front of b. So 8x minus, again, notice all of this disappears, 8x minus 2 squared. And again, when we look at these examples in a second, it'll help you to make a little bit better sense. Here is the difference of two perfect squares. 16y squared minus 225. Take about 30 seconds, see if you can make sense out of this one. Okay, for this one, 16y squared minus 225. This is the difference of two perfect squares. This is how you do this. 16. What is the square root of 16? 4. What is the square root of y squared or v squared, whatever variable you called it? Y. What is the square root of 225? 15. 15. It is the difference of them. So 4y plus 15 times 4y minus 15. Notice it's the same thing. 4y on both of them and 15 on both of them. One's plus and one's minus. Many times it's the difference of two perfect squares. That's how you do it. Let's do this one. This one's a perfect trinomial. 4z squared minus 12z plus 9. Think about 30 seconds on that one. Okay, for this one, it's the perfect trinomial. So right here, 4z squared is 2z. Because the square root of 4 is 2. The square root of z squared is z. The square root of 9 is 3. This sign right here tells you that minus goes in between them. 2z minus 3, and you square it. That's all you do for that one. Nope. Okay, so this is the answer. Let's watch what happens if we FOIL this back out. 2z minus 3. If it's squared, it's going to say 2z minus 3, right? So if we FOIL it, first is 4z squared. Outer is negative 6z. Inner is negative 6z. And last is plus 9. Combining your like terms, you get negative 12z plus 9, 4z squared. Notice that's the same as that. It's a special situation. It helps you just eliminate a lot of work. If you're talking about factoring a perfect trinomial. What about this one? Take about 30 seconds on this one. Okay, talk about your square root of 36w squared will be 6w. And your square root of 25 will be 5. This sign right here tells you plus, and that whole thing is squared. 6w plus 5 squared. Again, this is one of those special situations. Then factor in monomials first. This is the easiest part of this whole lesson. 12x squared minus 3. What number goes into both 12x squared and 3? The number 4 does. Oh, I'm sorry, the number 3 does. So right here, the monomial 3 is taken out. So it's 3 times 4x squared minus 1, or 3 times what gives you 12x squared, so it's 4x squared, and 3 times what gives you negative 3. So once you have that, now you have the difference of two perfect squares. 4x squared minus 1 will be 2x plus 1, 2x minus 1, and it's still 3 times both of those. B says 3u minus 9u plus 6. Again, the number 3 can be taken out. All of them have 3 in common. So again, this is the distributive property backwards. 3 times what gives you 3u squared? U squared. 3 times what gives you negative 9u? Negative 3u. And 3 times what gives you 6? Positive 2. So then you have u squared minus 3u plus 2. That's a perfect trinomial. I'm sorry, that's not a perfect trinomial, but you can factor out the number 2 and 1. And the plus tells you that they're the same sign. The minus tells you that they're both negative. So 3 times u minus 1 times u minus 2. And we'll finish the rest of this tomorrow.